Since we just looked at finding the angle between vectors, here we're going to look at finding just each direction angle of a vector, the horizontal direction, the vertical direction, and then the third dimension direction. Although this doesn't use dot product, it still kind of goes together with what we were doing. And then our last application will bring back the dot product. Now I used gamma here because that's what most of the books are going to use also. So we're given vector v. We want to find the direction angles. If you'd rather use A, B, and C, that is totally fine with me. So this would really just say cosine A, cosine B, although beta kind of already looks like B, and then cosine C. Our formulas for these are similar to what we just did with the angle between. We're going to take just that component, so A, over the magnitude of the vector. Again, kind of working with that whole idea of the unit vector, but just taking it in pieces now. B over the magnitude, and then C over the magnitude. So it kind of works out nicely if you use A, B, and C, uppercase for your angles, and then lowercase a, b, and c for the different components. So in our example, find the direction angles of the given vector. First thing we want to do, because we're going to use it for all three, is let's find out the magnitude. So here we actually want the magnitude first. We'll get 7. Now they don't always come out to nice values like 7, so if it doesn't, just use the square root. Be careful just with typing the stuff in. And then we have 3 different angles we're going to find. I'm going to use A, B, and C for this. So cosine A, we'll do -3 over 7. So you're just typing in your calculator inverse cosine of -3 over 7. Again, make sure you're in degree mode. We're going to get angle A is 115 degrees. Then we're going to do the same thing for the other angles as well. Cosine B is 2 over 7. So angle B is going to be 73 degrees. Again, plug in your calculator, inverse cosine, or second cosine of 2 over 7. And then cosine C is going to be -6 over 7. So angle C, cosine inverse of -6 over 7 will be 149. Just make sure to use what the calculator gives you. Remember, these are the principal values, although that's not really going to be an important thing on your mind since the calculator will give you the principal values. So that's if you broke it down into just the horizontal part, just the vertical part, just the third dimension part, what the different angles would be there. If you then wanted to keep it all combined, like we were doing before with the angles between, we have an application that we can do. So let's take a look at that. Right, in this application, it might remind you of stuff you've done in physics. We're going to do it a slightly different way with the vectors, although you might realize after we do it that your physics formulas kind of connect very closely to this. So we have W, standing for work, equals force times the vector that it applies to. So I'm just going to write in words what this is. It's the dot product of the force vector and the vector it applies to. So since I don't really have good skills with drawing pictures, the girl pulling the wagon is just going to be put into more of a coordinate geometry, or a coordinate system, I guess kind of geometry, just a way to kind of represent it. So the girl is pulling a wagon with a force of 50 pounds. How much work is done in moving the wagon 100 feet if the handle makes an angle of 30 degrees with the ground? So the 30 degrees and the 50 pounds, she's pulling it. I'm going to try to make this kind of look like 30 degrees. So that's the vector of the girl pulling the wagon. That's the force she's applying to it, is 50. And then we have 30 degrees here. And the wagon's starting at point A. We want to move it across the floor to point B, which is somewhere, I'm just going to put it here, 100 feet away. So I'm going to call that 100, 0, because we kind of want that value there. And then I'm going to put a little dotted line, get a right triangle going. So our force vector, as opposed to our vector for, I guess we can make that vector B, or AB. So our force is going to be kind of like what we did with the other application problems. We're going to use 50 times cosine 30 I plus sine 30 J. Now we could simplify this because we know values for 30, but if you didn't know the values, you could leave your force vector in this format. I'm going to do a little simplifying. So this would end up being 25 square root of 3I plus 25J. Is that a little easier to type in if you were going to use that as your vector? Probably, but you could leave it in the first format. And then we have the vector AB, which in that case, since it's just going across the floor, it's going 100 in the horizontal direction, and it's going 0 in the vertical direction. So you just kind of want to think about that, whatever force you're doing. If you're pulling something straight up, you would just have the I component, or the J component, and not the I. In order to figure out the work, we can do the dot product of those two vectors. So I'm going to move on to the next page for that. And remember, we're multiplying component-wise, so this will more remind you of your formulas because you probably multiplied the horizontal and vertical separately, or you figured out which way you were dragging it and just used that component only. So I'm going to call this foot-pounds. If you have other measurements that you know you can label it with based on physics, that's fine, but make sure you pay attention to the original example's information. This one was dragging it across by feet, and it was giving the force in terms of pounds. So you could put it as foot-pounds. Again, you may have another option for some of the answers for these. So I will require you to do this in vector, using the vectors with the dot product, although I know you know some physics formulas that will give you the same result in a very similar way, just maybe a little more broken down. And that's it for using dot product to apply with angles, to apply with this work application. So now you'll have a chance to work on the practice, either in class or for homework after.